Hey physics fans, today we're going to be working on text problem 9-63. It's one of the problems for 9.6, the chapter on center of mass. Now in the problem, it asks us to find the center of mass. So after doing our read step, we're going to find the center of mass. So we need the equation for the center of mass. The center of mass, shown as a position vector, is 1 over the total mass times the sum of all of our individual masses and position vectors away from some given reference point or coordinate axis. In our draw step, I've done a few things to help us out in this problem. First, I've drawn all of our given units in SI units. This will help us when we're calculating along the way, so we don't have to do any conversions and that everything will work itself out. Additionally, I've drawn our coordinate axis so that the x and the y axis encompass all of our points. So every single one of our points is either on the x-axis or on the y-axis. And this will help us once we get to calculating the center of mass in the x and the y direction. We're given all of the masses and distances, which are shown in the picture in your open text, and we have to assume that they're all point masses so we don't have to worry about the mass distribution of each object. In our solve step, the first thing I did was calculate the total mass of our system. We need it to calculate the center of mass for the entire system. And the total mass is simply the summation of all of our individual masses. Next, I calculated the center of mass for the x direction, which is 1 over the total mass times the summation of each of our point masses where x does not equal 0. Now x equals 0 on the y-axis, so our only mass that we need to sum up is our 0.1 kilogram mass, giving us the center of mass in the x direction. In the y direction, we're once again taking 1 over the total mass and summing up each one of our points where the y direction is not 0. So our only point where it is not 0 in the y direction is our 0.075 kilogram mass. And we can figure out what the center of mass is in the y direction. Because it doesn't specify how to report this, we can then just write these down in unit vector notation that the center of mass is the center of mass in the x direction in the I hat, plus the center of mass in the y direction in the j hat. And the whole thing is in meters. Checking on this problem, our units are in meters. We have one significant figure as given by our 0.1 kilogram mass or 100 gram mass in the problem. And this seems like a reasonable answer because it gives us a center of mass somewhere in the middle of our triangle. Thanks physics fans, and we'll see you next time.